let's say that we have a tree trunk here that we want to grab. What we would do is open the claw like this. It's just closed by a rubber band. Then we would move the arm in a way that the grabber goes around it. So now we grab the tree trunk and we can easily lift it. We can also tilt it, of course. Also, this can rotate now. You just spin this gear on the tool and it can rotate 360 degrees or more. I think these are pretty cool machines in real life, and this one just matches exactly how they look, and I absolutely love it. Also, I managed to reuse the John Deere stickers from another John Deere set. This is how you turn the superstructure. The machine does need some extra counterweight, it seems, but I don't have enough counterweight pieces, and I also think they're in another mod currently. This entire side of the machine opens up like this, which is pretty cool, and this gives you access to the inline 6 fake engine. As you can see, there's a lot of empty space in there, so it's totally possible to add counterweight. So let's leave that open for now. This door can also open, and look at the tracks. If you rotate them, the fake engine runs. The fake engine is driven through a differential. So this is what the underside looks like. It is down geared a lot because the tracks don't have enough traction sometimes, especially on flat wooden surfaces like this one. And as I've mentioned before, the biggest challenge of this machine was probably to get the superstructure tilting to work. This is the superstructure tilting system. It can tilt in any direction just using these two linear actuators on the undercarriage. It can tilt forward and backward and to the side as well. This is what it looks like when it's tilted to the side, which is pretty neat since you can now work on a hill like this while the entire machine stays level. So of course, first off I started with building the chassis. First I experimented with just a solid track drive that both sprockets are locked on a certain distance, but eventually I realized that we needed the tension on the tracks. Because otherwise it would just run a bit too tight for the tracks and it would cause a lot of extra friction. So here you can see one side without the track on it. It's just a spring and a mechanism to basically just lock it in place. And then we have the frame, we have gears here to a differential, which then goes to this, and this will go to a fake engine in the future. But then, after a bit of research, I realized these machines aren't actually just normal excavators with a green color and some extra stuff, but actually the entire superstructure can stabilize on top of the chassis in case you're working on a hill. So if the chassis stands like this, the superstructure would be able to correct that and be flat. I didn't realize that at first, but I guess it's an interesting challenge to stabilize the superstructure. So then I came up with this. This allows for movement in one of the two directions. It has a turntable as well for the superstructure, and then if we build that on here, we connect the CV joint in here, then click this all together. You should have something that looks a little bit like this. Now we have it can turn, it can go like this, and it can do this. So now I have like a full, basically joystick. Now I have to find a way to stabilize it. Also the drive goes through here through the CV joint. Let's do a quick test. Okay, that doesn't work, that's not great. I did something stupid with them. I went to the beach with them and now they're a bit stiffer than they should be. Yeah, that was a really bad decision. As in, like, never do that. Pretty much all of my parts in that mock are now damaged, or at least all the moving parts. And I don't know if you remember, but it was the compact excavator. Okay, so let's jump to the next part where I built some more on the superstructure. So after a couple more hours of designing on this, I managed to come up with this mechanism. It allows to basically move the turntable in all directions like this with these two gears, which then connects to a set of worm gears here. So you can move the turntable in all kind of directions. That would be if you're on a slope like this. One of them broke. That's something else I still have to figure out, how to make them a bit more stable. But I managed to make it surprisingly stable compared to the earlier versions, especially where it locks up against something else. Like in this position, it's very stable. For example, in the middle it's a bit more wobbly, but that's of course always gonna be a sacrifice with this kind of mechanisms. We might need a redesign, I don't know. I didn't even know it had this kind of tilting mechanism. When I started it, I thought it was kind of like an excavator. We'll see if I deeply regret this. So I managed to fix the stabilizing system. As you can see, it now has two linear actuators instead of the worm gear setup that didn't really work. If I lower this one, it tilts to the front, and as you can see, it needs some more counterweight. If I retract this one as well, they are both leaning forward, so that would be if the machine would be on a hill like this, that's how you would do it. Of course you can both extend them and they will go the other way. So with two knobs you're able to control the entire superstructure tilt pretty easily. And we also added a bit more to the arm. We have the pneumatic functions here. It goes up and down. This model specifically doesn't have a telescopic boom, while some other brands do. As you can see, I finally fixed the lighting, so let's now go on to the next part. I added a bunch of bodywork on the back, as well as an inline-6 fake engine that you can see here. So yeah, I think it's pretty cool. I moved the superstructure rotation to this side because it was just more convenient for the other stuff to be in the cabin. So now you can still rotate it, but you just have to reach over to the other side. It clearly still needs counterweight, which is something that I'm gonna work on, but my counterweight pieces are in another mock currently. Then we have 3 valves, 2 here, 1 and 2 in the cabin. And now we have the third one, which is controlled by this piece here. And we have a pump. So if I use the pump to get some air pressure and then lower the boom, we can of course raise it back up, which is controlled by this piece here with the valve that is hidden. And then we have the other function, which is the other valve here in the cabin. If I pump and switch the valve, you can see how the head tilts. Now you know how that works. Then we have this here, which is for a hinge. And guess what? I made more body panels for this machine. We can now put this, line this all up, put that in there. And if everything goes well, I can just push one axle that's 12 studs long straight through it, and then that locks everything in place. If we now connect the cylinder like this, we now have the hood that tilts open like the real one. stays closed pretty good. If you know, give it a little extra push. This door opens, and it also opens like this, so you can inspect the engine. Everything can be closed up, and now the back of the superstructure looks pretty much finished. So the final two things I did are fixing up the cabin. It now finally has a cabin, as well as fixing this claw mechanism. I'm working on even more forestry machines in this scale. For example, this logging truck. I designed it together with someone else, fully digitally, but I need someone to test it. So if you're willing to test a mock like this, let me know in the comments, and we could maybe arrange something. You get free instructions, and if you test it for me.